My name is Dr. Yap Ban Ha, and I will share this problem with you. There are two pizzas. They are both the same size. You can see that I'm showing you half of a pizza. And here I'm showing you 1/3 of a pizza. Two friends, Spiky and Curly, they are having an argument. Spiky thinks that 1/3 of half and 1/2 of a third are equal. But Curly disagrees. She thinks that 1/3 of 1/2 and 1/2 of 1/3 are not equal. Our problem is to decide who is correct. You have concrete materials like pieces of paper to help you solve the problem. We will let one piece of paper, one rectangle to represent one pizza, and the usual stationery. Talk to your friends about this. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. Let's use the pieces of paper to show half. So that's really half. And 1/3. 3 equal parts make 1. So that is a third. Can you now see how we can show 1/3 of this, 1/3 of half, and 1/2 of this, 1/2 of 1/3. So that's half, and this is 1/3 of half. 3 of this make half. So this is 1/3 of half. And that is half of 1/3. 2 of this make 1/3. So that part is half of 1/3. Are they equal? They are equal, although they don't look like, because 6 of this make 1. So this is 1/6. And this is also 1/6 because 6 of this also make 1. So Spiky is correct. 1/3 of 1/2 is equal to 1/2 of 1/3. If you find the diagram in method 1 difficult, you can try this other way of drawing a diagram. This is 1, so this is 1/3. 3 equal parts make 1, that is 1/3. Can you imagine half of 1/3? We can draw it like so. This is half of 1/3. 2 of this make 1/3. So this is half of 1/3. Likewise, I can show half. This is half, and that is another half. Two equal parts make one. That is a half. Can you imagine cutting half into thirds to get 1/3 of half? We can do it this way. That will be 1/3 of 1/2. Three of this make 1/2. So that is 1/3 of 1/2. The question is it true that 1/3 of 1/2 is equal to half of 1/3? Now, is this diagram better than the previous one? And from here, we can see that 1/3 of 1/2 is indeed 1/6. 6 of this make 1, so that is 1/6. Likewise, half of 1/3 is also 1/6. Method 2. We can also use calculations to help us. What is 1/3 of half? And what is 1/2 of 1/3? 1/3 of half may not be so obvious, but 1/3 of 3 is quite easy. 1/3 of 3 is 1. Is 1/2 equals to 3 something? That is right. 1/2 is also equals to 3/6. And 1/3 of 3/6 is like 1/3 of 3 anything is 1/6. Likewise, 1/2 of 1/3 may not be obvious to a lot of people, but 1/2 of 2 is easy. Half of 2 is 1. Is 1/3 also 2 of something? That is right. 1/3 is also 2/6. 1/2 of 2 is obvious. Half of 2 is 1. Half of 2/6 is simply 1/6. This is method 2, where we use equivalent fractions to help us. Method 3. Some of us notice that how interesting that the denominator in the product is related to the denominators of the numbers we were multiplying. 1/3 denominator is 3, 1/2 denominator is 2, and then the product, the denominator is 6. Do you notice how 6 is related to 3 and 2? Some of us think that when we multiply 1/4 and 1/2, we think that we do know the product is 1/8. You can check using the previous methods if you're not convinced. Likewise, the product of 1/3 and 1/4 is 1/12. In method 3, some of us think that the denominator in the product is related to the denominators in the numbers we are multiplying. Is 8 related to 2 and 4? 12, is it related to 2 and 6? If you are using method 3, you should be able to explain why this relationship is true. And the question is is it true all the time? Can I always get the product of two fractions by simply multiplying the denominator? Can I leave that to you? Today is a clever day. We have method 1, where we use diagrams to help us figure out whether or not 1/3 of half is equal to half of 1/3. And then we have method 2, where we use equivalent fractions to help us figure out whether 1/3 of half and 1/2 of 1/3 are equal or not. And finally, in method 3, we use an interesting pattern that some of us notice to do the calculation. In today's lesson, you have learnt it well if you understood one of the 3 methods. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Polya, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities and exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation that is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scamm's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in method 1. For average learners, they should be able to come up with method 1 and method 2. And if they're advanced learners in the class, method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.